Okay, hi everyone, welcome back to this video series on Introduction to Firewalls. Chapter 11, Creating Demilitarized Zones with a Single Firewall. The hosting of services on the internet requires that you expose a portion of your network to the internet while preventing access to your private network. Although a single firewall between the internet and a private network and provides security for smaller businesses, many large businesses require a dedicated segment of the network be established for protecting internet accessible resources. The common term for this segment of the network is a demilitarized zone, or DMZ. This chapter examines the basics of configuring a DMZ using a single firewall. Topics include how a DMZ protects your network, typical DMZ configuration, and how to define firewall rules when using a DMZ. Looking at the demilitarized zone. A network DMZ is similar to an actual DMZ found in war-torn countries. The DMZ, in the military sense, represents land near the borders of two warring countries, which by mutual agreement can't be entered by either side's military. A network DMZ resides between a public network, typically the internet, and a company's private network. Other similarities between a military DMZ and a network DMZ include all traffic that enters and exits is inspected. In a network, the DMZ is probably the most secured segment of the network because all data that enters or exits the DMZ is inspected against the firewall's rule listing to determine whether the traffic is approved to enter or exit the DMZ. Resources in the DMZ are inspected to ensure that security is not compromised. Many companies use intrusion detection software in the DMZ, both on the network itself and each network device located in the DMZ, to identify attacks launched against the resources. The intrusion detection software immediately informs the firewall administrator that a suspected attack is taking place. DMZs act as a protective boundary to the private network. By placing internet accessible resources in the DMZ, a firewall can be configured to prevent all access attempts to the private network from the internet. Only access attempts directed to the DMZ are permitted by the firewall, as long as the attempts use only approved protocols. Examining typical DMZ configurations. Network administrators deploy two common configurations when deploying a DMZ to protect internet accessible resources. Three-pronged firewalls. The three prongs refers to the use of three network cards in the firewall. Each network interface card represents one of the prongs of the firewall and is assigned to a zone of the network, a private network zone, and the internet zone, and the DMZ. Multiple firewall DMZs. The deployment of a DMZ using multiple firewalls is discussed in Chapter 13. This chapter focuses on single DMZ configurations. As shown in Figure 11.1, a three-pronged firewall uses a single firewall to protect both the private network and the DMZ. This configuration saves money because the company has to purchase only a single firewall. This configuration can also be considered a security risk. However, because if the firewall is breached, the attacker can gain access to the private network as well as the DMZ. Not every firewall product supports three or more interfaces. If your firewall product supports only two network interfaces, you won't be able to deploy a single firewall DMZ configuration. Figure 11.2 shows a typical multiple firewall DMZ configuration. In this scenario, two firewalls are used to separate the DMZ from both the private network and the internet, although additional costs are associated with the additional firewall. This configuration is believed to be more secure because an attacker has to breach 2 firewalls in order to access resources on the private network. You can see here figure 11.2, a DMZ using 2 separate firewalls. Designing 3-pronged firewalls. You must make any decisions when implementing a 3-pronged firewall. These decisions include weighing the pros and cons of deploying a single firewall DMZ and deciding how to handle IP addressing assignments based on the protocols that must pass through the firewall. Pros and cons. After you decide to create a DMZ to protect internet accessible resources, you need to decide how to use it to provide the best security. A single firewall with 3 or more interfaces offers many advantages. Lower costs. By using only a single firewall for your DMZ solution, you reduce the costs associated with buying 2 or more firewall licenses and the hardware required to host the firewalls. Simplification of zone definitions. Each network interface card in the firewall represents a zone that must be protected. A 3-pronged firewall has separate zones defined for the internet, the DMZ, and the private network. By deploying zones, you can define the security policy for each zone. The security policy assists in defining the necessary firewall rules to provide the required level of security for each zone. Firewall rules listings to maintain. With only a single firewall, only a single rules listing must be maintained for incoming packets to the network. This reduces the complexity for firewall rules when a protocol must be passed from the internet to the private network through 2 or more firewalls. As you can guess, deploying a DMZ with only a single firewall has some disadvantages, including your network has a single point of protection. If an attacker compromises the firewall, he has access to all segments of the network connected to the firewall. This includes both the DMZ and the private network. The length of the inbound and outbound list of firewall rules creates complexities. All firewall rules are included in a single listing for the firewall. The number of firewall rules that are created can make it difficult to determine why a firewall rule exists in the listing in the first place. Be sure to create detailed documentation on why firewall rules exist and what purpose it plays in order to reduce the effect of this disadvantage. The firewall can become a bottleneck. All network traffic that passes between the internet and the DMZ and the private network, and potentially the internet and the private network, must be inspected by the firewall. This can result in the firewall becoming a bottleneck and reducing the performance between the network and the internet. Addressing decisions. After you implement a 3-pronged firewall, the next decision you must make is what addressing schemes to use for each zone attached to the firewall. Typically, your organization will want to take advantage of network address translation in order to protect the private network addressing scheme from the internet. From the DMZ, the decision on which addressing scheme to use is based on the protocols that must access resources in the DMZ. 2 protocols that may not be able to pass through NAT services are Internet Protocol Security, IPSec. IPSec protects data by either signing the data or encrypting the data, preventing NAT from translating the IP and TCP or UDP headers. Because the NAT process has to be able to read these fields in order to work, NAT services don't mix too well with IPSec. Kerberos authentication. If a Kerberos implementation uses the client address CADDR field, Kerberos authentication fails if the NAT process replaces the sourced IP address information in a Kerberos authentication exchange. The authentication fails because the contents of the CADDR field must match the source IP address in the IP header of the packet if the two fields don't match. Authentication fails. Implementing private network addressing in the DMZ. If you're not using protocols that can't cross a NAT device, consider using RFC 1918 private network addressing in your DMZ as shown in figure 11.3. As shown in figure 11.3, the DMZ uses an RFC 1918 range of addresses 192.168.1.0/24. All servers located in the DMZ in this example are assigned IP addresses in the 192.168.1.0/24 network range. The private network in this case uses addresses in the 192.168.2/24 address range. Although this is a private network address range, the firewall doesn't need to perform NAT on packets that are transmitted between the private network and the DMZ. NAT is performed only when a packet arrives with a public network address that is destined to a private network. So you can see here our private network 192.168.2.0/24 and the DMZ 192.168.1.0/24 and 23.16.16.0/24. Finally, the external network must use an IP address assigned by your Internet Service Provider ISP. In figure 11.3, the public network addressing scheme used is 23.16.16.0/24. Because the firewall is performing NAT, the firewall must also be configured to perform static address mapping for all services located in the DMZ. The static address mappings map specific IP addresses and ports advertised on the internet to IP addresses and ports located on the DMZ. For example, if the internet advertised address for a web server on the internet is 23.16.16.20, but its true IP address in the DMZ is 192.168.1.25, a static address mapping must be defined as shown in table 11.1. Implementing public network addressing in the DMZ. If you require internet connectivity resources that implement protocols that can't pass through a NAT device, you must use public network addressing in the DMZ as shown in figure 11.4. So in this scenario, the public network address range is 23.16.17.0/24 is used in the DMZ. Remember that you can't just grab any public network address. You must acquire it from your ISP to ensure that the internet routing tables know how to route data to and from your network. You must own both the externally accessible address range and the address range used in the DMZ. Most commonly, companies simply subnet their addressed range of the IP addresses so that the required number of IP addresses is available at both the external network and in the DMZ. NAT is still performed by the firewall, but only on traffic that enters or exits the private network. No NAT is performed on the traffic that enters or exits the DMZ from the internet. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.